Hi, my name is Drew Tiagi, and today I'll be talking about how touchscreens work. So touchscreens are a really fascinating technology that really have changed how we utilize machines and digital tools. For example, before touchscreens were invented, and before we were able to use touch as a way of inputting to machines and devices, we had to use analog buttons and devices such as buttons, push buttons, potentiometers, and switches to provide inputs to a machine. But now, because of touch, we're able to more seamlessly and naturally input data and communicate to a device via our fingers. So there are two main types of touchscreens. The first main type is called resistive touch. And so the names kind of give up how they work, but I'll explain them in more detail how they work. So resistive touch is used on older devices, and it's even used today in some applications such as ATMs and fast food kiosks. So those kiosks you see at McDonald's with a menu, those usually use resistive touch, and they're sometimes a little annoying to use because resistive touch is a little worse, than the other type of touch we'll be going in this video. So resistive touch, how it works is you have multiple layers. So the first layer is your glass. This is a layer that you're not interacting with. It's hard, it doesn't move, your glass layer. And then in between that you have a conductive layer attached here to the glass, on top of the glass. And then you have your layer here, and this is usually made out of plastic. This layer you want to be flexible. And this plastic also has a conductive film on this side. And so this conductive layer here is made out of this material called ITO, or indium tin oxide, which is basically this transparent metal-like material that can conduct electricity. So the idea is if we put these two layers really close to each other, like so, and we separate them, using these things called spacers, which are these like tiny clear dots to make sure that the screen is separated, two layers. And if we apply a pressure point, such as our finger, here, right, what's going to happen is that this plastic layer, it's plastic, right, so it can bend, it can deform, and so the idea is this plastic layer is going to bend and it'll create a connection between the two layers, like so, okay? And so what I didn't explain yet is that these two layers, right, you can imagine these two layers, they form sort of like a grid, like, area. And so when you press your finger onto this area, what happens is it activates this circuit area here. So it completes a circuit here, and your phone is able to detect, okay, well, because it completed a circuit here, I know that the position is right there because, the voltage I'm experiencing is coming from this direction. And so when the two connect, your phone can detect the voltage and determine where on screen it's being, pressured at. And to be more specific, the actual science behind this, we can imagine that we have two lines. Let's call this one our ground line, and let's call this our 5-volt line, right? And we can imagine if we apply pressure, so we put our finger here, it's going to connect these two lines, right? And so what we can do is we can say, okay, how much voltage am I actually experiencing here? Because it's closer, we can say, okay, maybe I experience 3.5 volts. Now, if I push it up higher, like maybe up here, since it's farther away, I'm going to experience less voltage. So maybe up here, I experience only 1.5 volts. And so based on this, we can put a processor here, right? And this processor can record how much volts it feels, and based on that, it can determine where your finger is, on this axis. And the idea behind a resistive touchscreen is you first, you send a signal here, and you detect the left and right position, and then you send the signal here, and this is in the up-down position, right? So it's up-down, and so you can detect the X position and the Y position by scanning 2 times. You're scanning again for this voltage and seeing what the voltage is, and determining what the position is based on how much voltage you're experiencing in both these axes. So the cons, why don't we use resistive touchscreens that much? So the main cons are you need pressure to work, right? So it doesn't really work all that well because you have to really push at it in order for it to actually work because it relies on pressure to work. You also can't do multi-touch. Again, the reason why is because of the way it works. You only have one sensor that senses the touch input. So you can't do multi-touch. And also it's much less sensitive, so you can't detect like pressure or really granular exact positioning, because again it's just not up to that standard, that capable. But then why do we even use it in these older devices, ATMs, capacitors, etc.? Well, the main reason is cost. I mean, cost is obviously the reason for a lot of stuff, but cost is the reason, and also durability. These are much more durable and easier to maintain than capacitive touchscreens. Okay, so capacitive touchscreens, that's the other type of touchscreen. And capacitive touchscreens, how they work is a little different from resistive. So capacitive touchscreens. So capacitive touchscreens, they have a layer of glass, right, in front. So this is the front, your finger's gonna be here. So instead of actually pushing down and applying pressure, there's a layer of glass that stops you from actually, bending or deforming the screen, which is what you do for resistive touch. Instead, you have a layer of glass here, and then you have a diamond-shaped conductive grid here, and then you have an insulator in between. So these are all just like films, right? These are all just like tiny films. And then you have another diamond-shaped conductive grid there. And so if we look at these system a little closer, what we basically have is we have a bunch of these conductive materials. Again, these are probably ITO, and this orientation in just like straight lines. And then we have an insulator in between. So an insulator basically stops these the electricity and the protons and electrons that go between here and here. So the insulator stops that. And then you have another set of conductive lines in this arrangement. And so then when you combine the two, what you get is these diamond-shaped grid layout like so. So you have this layout like this and like that. And so what you do is you apply a positive charge to this top part, and then you apply a ground charge or a negative charge to the bottom layer. And so what happens is you get proton buildups here, so you get protons building up here on the top layer, and meanwhile you have electrons building up here. And what happens is that these protons and electrons, they clump, or they attract each other at these intersection points. Okay? And so at these intersection points, you have these bunch of these electrons and protons separated by an insulator, and what these do, because they're not moving, they create an electric field. And so looking at this more carefully, at this intersection point, what you have is you have an electron, and you have a proton, and then you have your insulator, right? And so what happens is you have an electric grid as created as a result of this setup. So you have an electric field, not electric grid, a field that is created as a result of this system. Okay? So electric field is created, and this electric field is created at every point along the grid, so along every intersection point of the grid. And then basically what happens is when your finger interacts on the screen, it's like interacting here, your finger has a charge. You have water, you have these salt molecules in your finger, and what this does is this has its own charge. And so basically when you place it close to the screen, you're inducting some of that electricity into your finger. And so this induction, so your finger is a little conductive, right? And so this induction, what it does is it kind of takes away some of these protons, and it attracts it closer to your finger. And what this does is it messes up the electric field. So if you imagine your finger here, and we imagine the proton, okay, so some electric field's gonna go up to here, and it's kind of messing up the whole electric field, and it's reducing the, this is a capacitor, right, because we have a electric field that's occurring. And so what it's doing is it's messing up the capacitor's strength. yeah, so anyways, messing up the field, and it's pulling away charge, which messes up the capacitor's strength. And then you basically have a processor or some kind of sensor that detects, okay, well, I see that this is changing because there's a change in this field here that's not being shared anywhere else. Therefore, the person must be touching at this point. And using pressure, the harder we push, the more this field is going to be distorted, and we can detect pressure via that. And again, to detect where we're pushing, we scan. So we do a scanning of the grid to see where we have any disturbances in the fields. And yeah, that's how touchscreen works. Thank you all for watching, and I hope you all enjoyed. Thank you and goodbye.